the quick design then for a Vise Jaw, and this one turned out to be the metric jaws, went through and created a slot. And I'm not 100% sure on the numbers because this is going to be an M12 by 1.75. And so I know it's about 12 millimeters through, and I kept it kind of tight, kept it snug, because I want to be able to flip this over with a 2-inch piece of material. Then I came in 25 millimeters off the top, 25 millimeters off the bottom. So when I measured the vise and I back calculated center positions, I'm at 984, which means that a 2-inch is going to be just that much off of center. So I don't have a very big slot there, but there is still just a little bit of a flat that I'm going to have to contend with. And then off the top of my head, I know that the 12 millimeter socketed cap screw is going to have a 12 millimeter height, but it's probably, I just took a guess and made it back to 3/4, so right there at 19 millimeters. All right, probably a little on the small side, but it gives us a starting point. And the intent here is that we talked about CamWorks last time, and I want to take something a little less complicated than 2-23 with all the holes and the geometry, and just run through a basic process of, if we start off with 1-inch steel, it probably is pretty close to 1 inch. And I will probably end up at 990. Is that a concern? Not really. As far as the Vise Jaw height-wise, my tallest parallel, 1/875, so I'm going to have 1/8 of an inch to clear to the top of the, from the top of the Vise Jaw to the parallel. I'm good with that. I mean, if I adjust it, and even it being mild steel, if I happen to run into it, I'm not near as concerned as if I were to harden and have to grind the surfaces. All right, so all of this is adjustable, and the advantage of this over the standalone Mastercam Gibbs is they have their methods and strategies of changing geometry and then re-importing it. But what we've seen with HSM and the little bit of CamWorks, and now with Mastercam for solids, I went ahead and uninstalled my 2017 demo version, and I put in the 2018 version. Mainly because it'll work in 2017 and 2018. I really didn't expect my 2017, and there was some issues that I want to see if they actually got resolved. So all of the lives inside of Solidworks CAM packages are doing the same types of things. The advantage of the Mastercam interface is this is identical to the standalone interface. The selections are different. The things that we're having to tell it to do are a little bit different. But this is what we look at any of the Mastercam videos. This is the toolpath group. Okay, so same types of things. We're going to go into the files, and I haven't set a machine or really gotten that far. I just picked up the mill default, and we're going to stay with that. If I need to, I'll change over to the Haas. But in demo mode, I'm not posting anything out anyway, so I'm not overly concerned with it. If this doesn't get too long, which hopefully with our standard geometry, I shouldn't be shouldn't take too long to just run through a facing, contour, some pocket operations, those types of things, and get into the mix. So the tool settings, same things we've been doing before. Program number 1, sign tools, worn, don't necessarily care, but if we I've jumped over that one enough in the other 236 class that inside of the tool database, like we're building in HSM, like we built or seeing in CamWorks, the tool can have these items assigned to it, and then when we select that tool, I can tell it I just want to see its parameters. Go ahead and put those in, and then I'll override them if I need to. Sequence numbers, I've gotten away from using sequence numbers at all. If there's a program that I'm having problems with and need to debug, I can always go turn them on. So HSM, CamWorks, I typically don't tell it to even bother with sequence numbers, right? That in 1 through 10,000 doesn't do anything for me, and it's just more data to transfer to the machine. And then Not overly concerned again with the material, it's aluminum, but if we go into select, we're going to pick up a mill library and switch over to 6061. And the main reason is that if I tell it to go with the combination of material and tool information, it has an accurate tool. Tooling has accurate material to work from. So as far as the stock setup, doesn't matter which one you're in. This is still a little strange to me, but pretty much the center of the stock is the stock origin. So when we tell it to do a bounding box and all items, so if there was multiples, it would find all of those, geometry, corner point, center point. Basically, we're just going to grab all items. It goes 1 inch by 6 inch was Y, but that's given an orientation that's up and down. So I have not set my plane correctly. So I really wanted the, well, let's see if it'll let me have it. No. So in that orientation, that is a correct number, but that's not the machining direction. So I didn't pay attention to my stock when I started there. All right, so now I'm going to have to dust off some brain cells again. And let's see the stock setup. Oh, let's go to the stock setup. And we have the front, which will give me a direction, but we're off just a little bit that way. Well, let me have the offset. I'm going to have to go back and find the standard planes. That's what I'm missing. All right, so bounding box, Y is 1 inch. Let's try again. All items. All right, 2 inches in Y, 6 inches in X, 1 inch in Z. That makes sense. All right, so Mastercam, plane manager. We've set up for the front orientation. Origin is 0, 0, 0. But for that current, and actually I want to set everything to that front plane. So the WCS is now in the front, the tool and the offset is all set in the plane. And my Z value should be 1 inch to raise it up. All right, so we go ahead and accept. That pretty much moved that reference triad from the back up to the top of the part. So that puts me in a correct orientation to touch off and make my tool movements. All right, so we're going to save the Vise Jaw. All right, so standard operations: face, contour, internal geometries, drills, pockets, however we want to approach it. Problem with this is going to be that this is still fairly small geometry, so dropping a 1/2 inch end mill in there is probably not going to work. Quarter is probably going to be a little bit small, especially with a 3/4 inch length of cut as a standard length of cut. And that's one of the questions that I get often is, where do you get the length of cuts? Is you go out to any of the tool vendors and you look down through their list. Most of the time, a 1/4 inch end mill is going to have a 3/4 inch length of cut. A 3/8 will be 3/4 to 1 inch. A 1/2 inch will be 1 1/4. Sometimes they're 1. Sometimes most of the time they're 1 1/4 though. All right, so it's kind of a best guess. The other thing is you walk out to the shop floor, you find the tool that you're going to use, you put a pair of calipers on it, and then you know what the length of cut is. And if you have 100 of those end mills lying around, then that's probably going to be your length of cut for a while. All right, so that's get used to it. So running this facing operation, do I have a 2 inch face mill at my disposal? Going into the steel, maybe I could do a single point fly cutter, but I would have a little bit of tearing. Making that choice again, do I take my 1/2 inch 4 flute? Because again, these are steel. I'm going to go to 4 flute carbide. Running back and forth across this face, is it going to generate those little waves or that little surface imperfection? Am I going to grind this after the fact? If I'm going to grind it, then I really don't need to do the facing operation. I could just go ahead and say flatness, parallelism, perpendicularity. If I get all of those, then I've satisfied my my conditions. All right, so going into the facing operation then, I have everything up here. It takes me too long to read through these and figure out where the pull downs are, so I am still on the right mouse button. In HSM, I'm on the right mouse button. In CamWorks, I'm on the right mouse button. It's great that everything's on the command manager, and I will slip up there every once in a while and go, hey, that's something that I can use, but for the most part, I'm looking at, there's my face operation. It's in the same place all the time, and I don't have to look for it. All right, so orientation is the Mastercam front. Face we want to cut is that. And for the face, outer loop only on faces. So ignore, this is not an island. This is not something that you need to avoid. And then the chains, we can just double check, and it finds its way around. Everything's, that little arrow is the same, pointed to the inside. Can't really do anything. Don't really want to do anything to the outside, so good to go. All right, so this should have found a decent sized face mill. And so the only thing I would probably change is going to a 3-inch, either 2 or 2.5. 2.5 or 3-inch. There again, need to walk out to the shop floor and see what's sitting there. But notice that this isn't a library or isn't in my tool list yet. We haven't brought anything in from the library, so there's a mismatch there. And then 23 thousandths feed per tooth. Yeah, I don't think so. 50 inches a minute at 1,000 RPM, that's a little scary. We're going to be shooting for a 128 finish, so a nice wave throughout the entire part if we're going 50 inches a minute. Even taking a 5 or 10 thousandths cut, we're going to chatter the heck out of this thing. So spindle speed, I'm pretty much okay with 1,069 on a 2 or 3-inch. The 550, maybe we would look at 600 as a surface speed, and that's at the upper end. That's 6 times my high-speed steel number. So 1146, probably pushing it. So 500 would be at 955. So just juggling those numbers, nice even number, 1,000. All right, and then the issue here is that we've told it that it is a 2-inch facing mill, which means it either has 4 outside chance of 5 inserts in it. All right, so that even at 2 thousandths chip load is going to play a part in it. And well, until that gets added. So let's see if we hit the plus. Nope, it's not bringing it over. So let's go ahead and add it. Turn the filter on, make sure nothing's selected, go into the face mills, and we're actually going to bring in the 2-inch. So it took its guess, but I really want to see tool 1, have it named tool 1, even though it's still giving me all that information over here, so that I can go back and double click on that value and see where the properties actually fall out at. All right, so number of flutes 2, no. I'm going to say that a 2-inch is going to be 3 or 4 flutes or 4 inserts. All right, so that should update. Goes from 2 to 4 thousandths per inch, thousandths per feed per tooth at 1 thousandths chip load would generate 4 for 4 inserts. All right, so reasonable. It's not going to scare me when I get to the machine. I'm going to see what it does for the finish and then go on. And then rapid retract is okay. Plunge rate, if that's 4, then as a feed rate, plunge rate can be 5. I really don't want to see that face mill do any plunging at all. All right, it's not a center cutting tool. Plunging would be bad. Okay, so set up for the facing operation. That's just establishing that top surface. Going into the cut parameters, one way it should be able to find its way all the way across. And actually, I can tell it go 1 pass. Since we're running around the outside, and there should be enough width, at the very most, I would expect to maybe have just a little bit of a sliver on the outside. And if that's much of a problem, I'll come back and say do 2 passes. But for the most part, I would like to have it take this in 1 pass.
Why don't you just go ahead and pick a 2.5 inch face?
Do I have a 2.5 inch face? Chances are I have a 2 inch, but I don't have a 2.5.
Okay,
All
it
right.
was in the library.
Yeah, you know, and again,
I mean, it's defined, but not necessarily found in the crib.
right. If you don't have it in the tool crib, you can call it whatever you want. And if it makes it easier, we can lie to it and say, yeah, it's a 2.5 inch. So you'll show me that it cuts all the way across, but I still have to go get my 2 inch at the end of the day and put it in there. So, you know, again, that juggling act, making decisions as we go, knowing what's on the tool cart, what's in the tool crib. That's where those numbers are going to ultimately come from. So I know that I have a 3-inch insert fly cutter, so one flute that I could take that pass, and so then I would jump up to 3-inch. Do I want to run it in steel? It probably has, since it's mostly in aluminum, it probably has a 40 to 60 thousandths nose radius. Not going to be the best for steel. We may degrade that. If it was a little bit lower, 15 to 30 thousandths, then I might be a little more inclined to put it into the steel. It's all gonna degrade after a certain point anyway. So, you know, what is the real function of getting this face, you know, flat and parallel without having to do the secondary operation of grinding if we can help it. All right, so, you know, again, best guesses, we'll get it out to the machine, we'll cut an extra part, and if I end up with an extra jaw, then great, I'll go cut another piece and make 2 extra jaws, so I have another set to go into. No depth cuts, and the linking parameters, 0.25, really would like to be absolute above, and that one, I believe, is new, associative, so I have a definition to go look up. Associative would pretty much be in reference to, looks like some kind of selection. All right, but I'm not sure of that definition, so I'm not gonna jump into that one right away. Still gonna say your best bets are to stay with the absolutes, and incrementals are gonna be a little bit more because are a little more accessible because we have these depths to pick from. All right, and then coolant. We'll go ahead and turn the flood on. I haven't been doing that. Planes, everything lines up across the Mastercam front. That's okay. So there's my path. All right. So did I leave enough of the end overlap and the side overlaps kind of go away because of the pass? Well, we'll see. All right. So the other thing was that if we're doing this as a material to remove off of the backside, then I am you know, I'm at 1 1/4, 1.5 inch material for this 1-inch jaw. If I'm clamping this down to my fixture plate and going to run around the outside to clean this up, have some slightly oversized material or, you know, again, the clean material, then I'm making decisions based on that geometry. So if I have 2 clamps and maybe 1 clamp in the center, because this is fairly narrow, or being 6 inches long, I can get 1 clamp. I could maybe get 3 clamps across the face and then switch them out. I'm still going to have to be careful leading in and cutting 3 sides and then coming back and changing the clamps. So I do want to see what that looks like. So we're going to give that a try. So I'm starting off with 1-inch stock, and to do the facing operation, well, I either have to put it in another vise, or I have to use something like Mighty Bites. And then the Mighty Bites hold this down, and then immediately I have to stop the machine after it does the tool change and add my toe clamps to do the hold down, so that when the end mill is coming through on the side, it's not lifting the part out of the Mighty Bites. And then get the pins and the other stuff out of the way so I'm not running into hardened dowel pins. All right, so again, that thought process of, wow, it's really easy to put it in the vise, but my material says that I'm going to have to hold this on a fixture plate, or I'm going to have to select different, or instead of a 1-inch vise jaw, I'm going to be making 3/4 inch so that I can use the 1-inch material and run around. All right, so we go through all of that process, and I'm still inclined to want to stay with the 1 inch thick. So we'll go with the machine stop. So we're into the mill toolpaths. We still need to come over to manual entry and enter the text. And we're going to go G00. Okay, maybe one too many. G90, G53. And even though those values are probably already coded, I don't want to find out that they're not. Right, so I'm going to go ahead and build those in. And then G53. And we'll go with Y0, M00. Change clamps needs to be in a comment. And go ahead and accept. All right. So one of the problems that I don't want to find out carried over from 2017 is that, well, until we get to the end, and I don't care anymore about the lecture, or don't care anymore about the this file, is that when we copied inside of the solids, it pretty much lost its mind and crashed SolidWorks. So we won't be copying any of these operations just yet. And I don't know if it does that in the commercial version. I haven't had access to really get in to be able to work with it. All right, so going into the contour, we're going to pick the faces. We are displaying selections, projected tool plane. Let's look at the chaining options. So chain tolerance pretty much comes into the mix. And then what are the selections? So we can filter out for, hopefully it's going to give me the tool tips. Looks like faces, surfaces, edges. That would be features, sketches, not sure, or edges or lines. Pretty much, whatever. I'm going to start picking. So go ahead and make the selection. And that's going to be the 3 sides. So the clamps are going to be on the front side. We'll go in. And pretty much my reasoning for putting them on the front side is when that tool's coming down to make, and I'm still going to do climb cut. When that tool's coming down, I'm going to have the best view of this clamp if I'm coming down on the side that is right in front of me that I can see. Other than that, we're checking direction. Cut is to the outside. We're making a climb cut. Feeds off. That's okay. Get into our operations for the contour then. We're back into the library tool. Set for the filter. None. In mill. Go ahead and accept. All right, so we're going through that process. We're always interacting with a tool library or a tool crib. We're always picking. Oh, where did it go? I filtered for it and then I jumped right over. All right, so actually select one. There it goes. Now I'm just getting button happy. All right, so I know from experience that I would expect at about 400 surface feet per minute that I would see about 30, 50, 30, 56. All right, and then the feed rate at 18 for a 4-flute. Well, are we at a 4-flute or are we at a 2-flute still? So this one did come over as a 4-flute. And let's go ahead and leave it at 1,000 and 12. I don't really need the 0.2, so because we cut these a little bit oversized, I'm expecting maybe a 30, 40 thousandths deep cut on the sides and pretty much just a little skin cut on the back, right, just to clean up, right, because material is not going to be much oversized. So I may have to make an adjustment that says, well, instead of this being 2 inches by 1 inch, based on my stock condition, I measured it, I want to take at least 10 thousandths off of each of the faces. So my new finished dimension is 1.98. Well, that may be an advantage because those 984s, if I, the 25 millimeters, if I put it at exactly 50 millimeters, I'm enough undersized that I have the cleanup, and I don't have to really do the ob-rounds. All right, so that's on the design side, design consideration, but that also plays into the manufacturing. All right, so contour sides and back. Cut parameters will stay in. And again, if I'm taking just a very light amount, do I take a spring pass, have it repeat the pass once, or do I try to do a roughing pass and then come back with a separate operation? So I'm going to say go ahead and turn compensation on so that we can control it. No stock to leave, no stock to leave on the walls or the floors, and we're just going straight 2D. Depth cut 1 inch with an 1.25" tool with that light radial engagement. I'm going to stay with it. All right, so full depth engagement, and then since we're engaging in the clamps, having it start out and ramp in, having that arc ramp in might be an advantage, as opposed to coming down next to the clamp on an extended lead out. So if we enter, we're going to enter at the end point. This isn't a closed contour, but I think at this point it's habit for me to turn that off. 1/2 inch, probably not. Maybe we'll go 0.1. So I want to reduce these because I really don't want to see it cutting all of that lead in, and it's not going to be that much of an advantage to get further away from the clamp when I still have to feed up to that edge. So I want a little bit more clearance to get a perspective of it, but huge amounts are not going to be helpful. So maybe 50% on the radius, and instead of doing a full 90, let's go 45. All right, so I'm going to drop that angle back so that I'm angled away from the clamp. I can tell it's coming down, and I know it's going to be about yay far when it contacts the material. When it's making that approach to the contour, I'm going to have a couple seconds to decide anyway. Does it look good and is it going to work, or do I need to stop it and check? So we'll have it do the same thing on the lead out. So transfer all that information over. If it turns out that this isn't any great advantage, then I would go, because this is rectangular, I would go over to adjust the start of contours, turn off the entry, and just say extend my length by the radius of the tool plus some value. And that would bring it straight off and pretty much stay in line, straight off and straight in, straight off of the part. So no breakthrough. Maybe since we're in the fixture, might go 5/1000ths, but it depends on what the facing, what the other operations did. All right, so no multi-passes stepping into the part. No tabs to hold it down to the connected part. And so our linking parameters, again, since we are going to be jumping over clamps, so probably 1.5 on the retract. And we'll go 0.1 on the feed. Top of stock is 0, and then we'll stay with the absolutes. Oh, it found it. I was going to say we can go in and pick. When I pick on the depth, then I have depth geometry that I can access. Otherwise, it already came up with a -1 inch. And then we'll double check the planes are in the front, colon is on, and go ahead and accept. So that little bit of an angle and that little bit of a lead in, I'm relying on that to tell me am I far away enough away from my clamp to make this work. All right, and then let's go back and edit, because pretty much I'm going to do the same thing. I'm a little really don't want to find out the copy thing just yet, so we're going to go to manual entry. Oops. Oh. Okay. Well, I guess I didn't need to copy because it kept everything from the previous one. So that was nice of it. I didn't remember it doing that. All right. So contour around. We're going to make that one pass, and then pretty much, let's see, we're going to pick up the next. So mill tool pass contour. and this is just going to be the one item. And when I'm making these selections, I'm still thinking in terms of climb, and I'm selecting towards the end that would put me in that direction. So when I identify the climb, well, that's the conventional direction. So same thing, we're going to have to change the side. All right, so expecting the tooltips, no. Okay, so let's change the side. Well, when I change the side, I'm still in conventional, I'm on the outside now. But when I change the direction to put it into climb, chances are I just flipped it around anyway. So my left compensation, my right compensation is a function of that direction. Okay, so all of the parameters from the previous contour hopefully came over. So 2 inches, 30-50 at 12, rapid retract, didn't check that on the other one. Look at the cut parameters, wear is on, nothing on the floor. No depth cuts, lead in, lead out stays the same. And no breakthrough, multi-passes, tabs, linking parameters, everything stays the same. Plane didn't change, we're just double checking, and the flood coolant is on. So all the previous contour parameters are still there. Right, shows that lead in, lead out. And the 1.5 inch is enough to jump over the clamps. And we said we wanted to try a spring pass, so let's see if so to do a spring pass, I would need to tell it to do multi-passes. I'll see if it'll allow a 0 spacing, but 1 spring pass. Finish pass at final depth. And no, we definitely don't want to keep the tool down because it's going to end over here and then go right through everything. All right, so go ahead and update. And do we see it jump back? Now I'm kind of looking for rapid, so we'll have to see if that picks up. My green background and the yellow for the rapids, I don't really see a line going across that it completed the spring pass. No operations, so yeah, we're in. So run one roughing. Finish. Okay, so there's some combination. I'm either going to have to add the 1 finish pass and the 1 spring pass. But basically we're not roughing anyway, so wonder if it's my logic or the software's logic. Okay, so my logic. It needs 1 finish pass to tell it to do 1 spring pass. Alright, so we would do the same thing on the previous. Multi-passes are active. No spacing on the rough. So that may have been where if I get 3, I would go back and turn off the roughing. And no spacing. Yeah, I'll see if it'll take it. Okay. So that gives me the round, has the clamps in place, and then I have to position the clamps where I'm not going to hit anything. All right, when I start to either drill the holes or to perform those contours. All right, so positioning the clamps when we do this this path is a little bit more critical now. Want to stay close to the edge on at least one and interior on the other. All right, so this is looking more and more like I should just make a 3/4 inch clamp and sacrifice some of the material on the back side of the 1 inch. I'm undecided as of yet. So design changes in the works. Revision B. All right, so let's go ahead with oops, I'm not sure what I told it to do there. So mill toolpath. Oh, new. Jumped up to new instead of contour. Let's go with the drill, and we're going to pick the 2 edges. All right, so I just need to open those up with as large a tool as I can fit in there. So let's see, 12 millimeter point and point. All right, so those were both on the center point, or at least look pretty close to the center point. I'll select a library tool, filter for drills. And then let's see, we know that half inch is 12.7 millimeters. So that would have been the obvious choice to have a little more clearance. So let's go with a standard 7/16. And staying with the surface feet per minute, we might be just a little bit under 100, but 870. Feed rate, we want to keep that that tool pressure up, so 3.5. I just don't need all those other decimals, so we'll go with the 6. I didn't center drill this, so really it's going to be the first peck and the mild steel. I'm going to make sure to get a 135 degree split point. We're going to drill into the to the fixture plate, so we may have to go back and add a center drill later on. But if I can avoid adding that extra tool change, probably going to do it. All right, so stock, define stock. All right, so it should be default. That one's new too, I think. We're going to go with the peck drill, and one of the things, if we do the 100,000ths, 430, I mean my max depth to drill diameter ratio. All right, so if I were to do half, that would be about 0.22. Since I'm not starting with the center drill, I really need to reduce that, and that 7/16 drill is going to produce a pretty good sized chip pushing through this material. So maybe I'll drop down to 50 thousandths, which would put it more on par with like a 10% or close to 10% of the drill diameter. And you know, even if it takes those extra pecks, one of the things I could do is, if it's working well, we could switch it over to a chip brake, which would be a high-speed peck, and go from G83 to G73. And then it wouldn't do a full retract; it would just enough to break the chip and eject it. All right, so a few options there. The retract, we're at 0.1, top of stock. Let's stay with the absolutes. All right, so I'm okay with everything up to this point, but if I leave this clamp in the middle, when it retracts up 100 thousandths and takes over, I'm not all of a sudden not real fond of that retract plane. So this is where the clearance is going to come in, because I really don't want to start pecking 2 inches above and 50 thousandths at a time for three whole inches. We're going to build in the clearance, and I was using 1.5 inches, and so we'll stay with 1.5 inches. Use clearance only at start and end of operation. Well, that's not going to work. We still have to maneuver around those clamps. Coolant will be on. I'm not worried so much about the plane. And we'll double check that it's starting to peck from 100 thousandths, but the rapid is up and over my clamping operation. So if I decide that I'm going to make the design change and go to a 3, well, maybe not even a 3/4, I could probably get away with holding on to this with the 1/8 inch. So an 8.7, 860, 850. All right, I can juggle some numbers and get to maybe an 850 thickness. All right, so we're going to turn the displays on. All right, so that turns everything on, and then that gives me the ability to turn everything back off. All right, so it's going to turn on the non-displayed items the first time I hit it, and then it's going to turn them off as we go back through. All right, so I've got this starter hole that's removed a good chunk of material. If we go with a 3/8 inch end mill, so again staying with a 4 flute, question is going to be, do I want to tell it to do this as a slot? Well, the movement's only at this point 20 or 30 thousandths, so I don't know that that helps. So pocket and contour, I'd be more inclined for the pocket, but if I can get it to ramp, then I would say we'll go with the contour. So let's look at the pocket first, and maybe we'll try to pick it up on the next one. So when I have a chance to pick for depth, we'll go ahead and grab those geometries. And oh, I didn't turn on my my filters, my selections. All right, so I got to go back and look at that since I haven't set anything up really for the edge. Actually, I'm going to see if it'll let me pick just those two, jump over to the chain. Nope. How is it going to treat that as a pocket? Alright, so where is the connection? Plane, display selections. Alright, so if it won't let me have those, then how about the face? Alright, then we'll come over to the chain, except the chain picks the outside and the inside, so don't want that one. And oh, there it is. Okay, I'm hitting delete on the keyboard, but I need to come down and get rid of it at the base. Alright, so we'll make sure that the two chains that I kept are both outside and that they are pointing to the interior. Alright, so 3/8 inch tool. Selecting library tool, going back to the filters, picking our end mill. 375. Alright, so surface feet per minute stayed kind of on the low side. Let's double check that that's a 4 flute. So alright, so number of flutes 4. And we'll go with we'll stay with the 400. Alright, so just rounding those to zeros. And 0.001. That's a little, oh, I'm going to say that's pretty slow. Not real fond of the 628 or 16.28, mainly because it's such a small distance traveled, even for the pocket. So I'm okay with slowing that down to about half. We'll do the rapid retract and then pocket step 1. Cut parameters. I'm going to try and go no stock to leave, no stock to leave. And when I go back to finish, I'm just looking to basically act as a spring pass and clear up any tool deflection. So if we can go with the parallel spiral. Let's see, we said 3/8, so maybe 10% step over. Alright, might as well make that a little more even number. Entry motion, spiral or ramp. Well, I'd rather have the ramp first, considering what we're getting into, but probably we'll have to end up with the helix. Maximum length, well, we're not going to get either of those. So maybe 20 thousandths, and stay with the 100. And for that short distance, 3, well, we're going to have to take a look at what the result is. Finishing, 1 finish pass, 10 thousandths, no spring pass. Lead in, that's going to be way too big. Alright, but if we want to engage any kind of compensation, alright, so now we're telling it just computer, so we're going to shrink this down to very small. and transfer it over. And it will either work, or we will add a separate contour for it to go in and pick up that geometry. Alright, so it picked up. Well, that one's a little on the deep side considering what I picked, so 0.75. And that's going to be a minus. Or we're going to go into depth and pick a point on that face. Right, so minus 0.75 whichever way we go. And did the coolant stay on? Nope. So we're going to go ahead and accept that. Alright, so interesting that it chose that way because I was still thinking it would go that way. Alright, and then the other thing is that clamp in the middle just got the end buzzed off of it.
Wouldn't that be just easy on the machine to just helix down rather than zigzag? It's going to vibrate the heck out of it.
Well, at 8 inches per minute, probably don't like the direction more than the helix. So one of the things with the helix is that I guess my perception is that the length of time that it takes to make all of those loops and circles, unless you have a really good reason to make all those loops and circles, you're getting into a really tight spot and getting the clearance, the ramp is going to be faster and about as efficient. So it's kind of one of those 6 of one, half dozen of the other. You can make an argument for both. Also, depending on the machine, if the helix will recognize the GO2 with the Z value, it's not a problem. If it ends up generating a million little lines of points to generate that helix, pass. All right, so we're going to go back to the retract plane, and we're going to put that up at 1.5 and accept and go through the process. All right, so the one thing I said that it seems like it was a little longer this way. So on that entry motion, XY angle at 0, I'm not happy with, so I can change to 90. And we'll see if that looks a little bit better. All right, so it's still pretty much in. Have a very small lead in, but it moves over. Actually, it jumped up and went right back to it. So I don't know. That would be one that I'd want to see or look in the code to see if it finished that out with the contour or not. All right, and then same thing. All right, so pretty much this is going to be the test. I'm going to go ahead and save it. See if they Mastercam picked up the solution to the copy problem. All right, so I pretty much want this same operation since that looks pretty good, and I have enough clearance. I want it to go through the part. I'm going to say that my 3/8 inch end mill has an inch length of cut, can reach. So if I pick this up and copy, then I should be able to go to. All right, so I would take that as a no. All right, so I'm going to stand by I'm not sure what happens in the commercial version, but one of the issues that I've had with the solids, the Mastercam solids for Solidworks, is that copy wipes this out. I have a chance of getting that back because I saved it, but it's just one of those. What do I do with that? All right, so we'll see if it loads back up because I've had it recover, but it shouldn't even be happening in the first place. All right, so we'll see if it cooperates. All right, so I don't remember what I had to do to recover it. So if you're working in demo mode, working in the commercial version, make sure that you know whether you can copy or not, because in this particular version it's going to wipe your program. So one of these days I'm going to have to, I guess that would be a good thing to do tomorrow, is go ahead and put my enhancement request in with Mastercam. All right, so it's a warning, be aware of it. I hope it's not in the commercial, but hoping doesn't cut it. You got to test it and find out. All right, so other than that, all the selections, some of the things that I need to go back and refine some of the selections and and dial in some of those jumps, but basically I'm okay with what was generated.